So part 6 of chapter 8, 8.0 Cumulus Security, Cloud Computing and Security. When you finish this video, you have reached the 80% mark. You are 80% of the material that you need to cover for your ISC2 certification, and more important, 80% of the way towards, or 20% left, which is not much, towards having a great security foundation, cybersecurity foundation for whatever it is that you plan on doing within the information technology field. So again, when we think about cybersecurity, we think about training those cybersecurity, those red team, those blue team, those people that are going to work in the SOC. But again, security starts with everyone. So whether you're an end user just interested in cyber, or you're taking this lecture series or this class to earn a certification to break into the industry, I cannot stress enough how important it is that you gain every aspect and build that solid foundation. As we know, even in cybersecurity, there are many, many different areas of specialization that you can go into, all of which, and I'll just say this one more time, you need to have a foundation. So let's talk about future trends in cloud security. We'll take a look at AI in cloud, machine learning in cloud. It's not just there to do your homework. And then, of course, the impact on quantum computing. Now, some of this are the same sort of impacts that we've seen before as we talked about cryptography and encryption. Okay, but emerging technologies are going to impact cloud as well, both from a challenge standpoint as well as a benefit. Edge computing. So edge computing processes data closer to the source rather than centralized data centers. Okay, so we're going to reduce that latency and improve performance. So, while beneficial, edge computing expands the attack surface again, because suddenly, where processing, where storage and everything was happening just in the data center, now a lot of that may happen locally. And we already see this implemented in hybrid cloud, where we want things to process quickly, and it processes and then perhaps goes into a cloud sort of as redundancy or as an additional processing source further down the line within our application, if you will. Okay. So securing edge involves, protecting the devices, endpoint security again, data transmission, processing points, because those may no longer sit in the cloud. Okay. Similar to, when we had the the client server environment, a lot of the processing was done on the client. And then we brought all of that to the server because there was more resources for processing there. Thus, we didn't have to buy as powerful clients. And now we're kind of turning around and going the other way, where, a certain instance of the cloud that's processed regularly, all that processing might happen back on the client, so that we're not having to transfer data to be processed and then the processed data back and forth, creating, a lot of attack vector as more data crosses over. Okay. Machine learning and AI, well, we've talked about a lot of these, quickly analyze vast amounts of data, invaluable for detecting anomalies, for creating those baselines, for knowing what our network looks like today, and oops, here's something we need to look at immediately, potential threats, seeing changes in network activity, for example. AI can help us with a lot of this. So we are seeing AI not just implemented, from a large language model to help you, learn more. Remember my saying, use AI to learn, not to earn, right? So don't use it to write your paper, but use it to learn what you need to know so that you can write your paper, those kind of things, right? So we're seeing this as well from a cloud standpoint, the ability, more effective at predicting attacks, because again, we're teaching that AI that this in fact was an anomaly, but it's not an anomaly that leads to a threat. So we can just add that to the baseline, and when you see those again, we don't need to process those. Okay, so again, this could be a change in an application that produces an anomaly. We trust the application, thus, we let AI know. AI trains on more anomalies and, produces way less false positives, if you will. Okay, so AI-driven tools automatically isolate, comprise virtual machines. They can block suspicious IPs automatically. So it used to be, I remember when I'd put up a server, I'd go back a couple days later and I'd see traffic coming from China, traffic coming from Europe, whatever, that client didn't do business there, and I would block those IPs. Now that can happen automatically. Okay, so a lot of technology being worked in, and that was happening, by the way, before AI, and large language models, but it's going to happen quicker. We're going to be able to stop threats, such as, blocking IP addresses that we see are sourced with a DDoS attack, as another example. So, as enhancing cloud security, again, adaptive security systems dynamically adjust controls based on their current threat landscape. So again, it's not just about an overall threat landscape, but maybe there's a time when our threat landscape is increased. Maybe it's when we release a new product, for example, we end up with an enhanced threat vector, if you will, because all of this press is coming out, and when there's not that press, we don't see the number of potential attacks, but we can use AI to increase our model at that time within that incident. I saw some formatting issues here with no blues, no examples. So a spike in a phishing attempt is another great example. We detect that spike and we increase, our protection during that incident. All right, so quantum computing, we already know its impact as it pertains to encryption, and the ability to hack that encryption, if you will, to keep it simple, But quantum computing, could break existing encryption, as we've discussed. But again, we need to future-proof that stuff as it pertains. Now, there's also potential to increase AI and have it run faster, have it look at incidents, have it do more because of quantum computing. Okay, so again, we have that, as with the previous slide, we have that phishing incident that used to take 3 minutes to displace and secure against, and now suddenly it's detected it, it's made changes to the network, it continues to monitor. Once it sees that attack has been mitigated someplace else, we're not seeing it anymore, it takes our level back so that, perhaps in that process, it's actually disconnecting systems to prevent them. So, imagine quantum computing on a ransomware attack, where ransomware hits, it literally hits the first endpoint, and that endpoint is disconnected and other machines are disconnected along the way, okay, till we know we can mitigate that so that the ransomware attack can't propagate the entire network, okay? It's kind of making that one up, if you will. So just real quick, I do suggest that you pause. I'm not going to go through this in detail. We did talk about evolution of cloud computing, security principles and best practices, regulatory frameworks that we talked about, the dual nature of cloud computing, what are its advantages? We know the risks are higher in the way of attacks, additional vulnerabilities, additional impact from ransomware, not just encrypting our network, but encrypting the data of hundreds of thousands of people that are utilizing that particular resource, whether that be, cloud computing as a whole or application, whatever the case may be, right? Importance for cybersecurity defenders, digital cybersecurity professionals, whatever you want to call them, to be vigilant, to have a strategy, to deal with those compliance issues that are constantly changing. one new legal case may change the form of what GDRP looks like, for example. Okay, so again, it is beyond data protection. These are constantly evolving strategies that we need to implement, constantly evolving threats. Okay, and then with AI, LLM, whatever it is, as well as a cybersecurity professional, we need to anticipate threats. We need to ensure security. We need to implement innovation when it happens. So remember, cloud computing as a cybersecurity pillar. Cloud computing is not just a technical shift, but a pivotal element of modern cybersecurity. So, mastery of cloud security, read that second book, do more. If you're going into cybersecurity as it pertains to a data center, what you learn, what you need to know may be different than cybersecurity for a local business versus operating in a SOC versus doing pen testing versus being on a red team and a blue team, right? Even within cloud, what does it mean to be on a red team? What does it mean to be on a blue team? All right, so folks, that's it. We'll see you for chapter 9. We've got just chapter 9 and 10 to go. In 9, we'll talk about compliance, risk management, and governance. And in 10, we'll talk about incident response, business continuity, and disaster recovery. Take care.